So welcome back to my channel guys. Here today I am with the foundation design of a building. So what is a foundation? Foundation is something which acts as a platform of the building. It is in the direct contact with the ground and it transmits the superstructural loads to the soil. What are the uses of foundation? It distributes the loads to the larger area, that is for efficiently transferring the load so that there is no damage to the structure, and it supports the structure, provides stability to the structure from external agents like wind and rain, etc. So let us begin. Let's take a problem. So here we can see a problem with columns C1, C2, C3, C4 and so forth till C16. So this is the foundation or the foundation plan of the project that we have done in the previous videos. That is the same base plan. So you can see these are the foundation, these are the columns that will transfer the load to the soil. So the safe bearing capacity is 300 kN per meter square and allowable settlement is 1 centimeter. Now you can see the different loads on different columns. As you can see, C1 has a dimension of 500 into 500 with a dead load of 1850 and a live load of 797.6. The material of the column is also being given. So these are the dimensions of the column and the loads with respect to the project that we have done in previous videos. So now let's calculate the subgrade modulus. So subgrade modulus formula is given, which is equal to soil bearing capacity by allowable settlement. So 300 kN per meter square by 1 centimeter, which is equal to 3 into 10 to the power of 4 kN per meter cube. Now the column strip width. So the column strip width is calculated by 0.25 of L1 or L2, whichever is less. Here in our case L1 and L2 are both 18. So take any of them. 0.25 into 18, which is equal to 4.5 meters. Let's take 4 meters in our problem. So now let's begin with the problem in the software. So now open Safe 2016, go to File, New Module. So now design code will be IS456-2000 and the unit should be in metric. Here you can see currently in metric clearly. If you do not have the metrics, you can go to modify and click on metric defaults. So click on OK. Now go to design preferences and now go to minimum cover slabs. So for minimum cover slabs, in this clear cover at the top would be, as per the IS code, it will be 50, and for the next one also just edit it as 50, and the preferred bar size is, let us assume, as 22. Now rest all will be the same, just don't change. Click on OK. Now select the grid only option. Now in the grid only option, we will take X direction 19 and Y direction 19, because we have the space, we have the distance as 18, so the grid lines will be 19 automatically. So the number of spacing between each grid line, let us keep as 1 meter. So now click on OK. Now the first thing you will need to do is the defining of materials. Just go to define materials, add new material and click here as M40 because we are taking as M40. So M40, here material type will be concrete. So these values you can simply find in internet, so no need to worry about these values. So weight will be 25 kilonewton per meter cube, and modulus of elasticity E, the value is 31622.7. You can find these values easily in internet, so not an issue. Poisson's ratio is 0.2, you need to change it, and coefficient of thermal expansion is 0.0000055 per degree centigrade. So the shear modulus is the value that is present there only. So the strength will be 40. Now click on OK. So M40 has been defined. Now let us define the HYSD 500. So HYSD 500, material type would be rebar. So the weight per unit volume is 77 and E is 2 into 10 to the power of 5 Newton per millimeter square, and that 5 would be 500, and minimum tensile stress Fu would be 545. So click on OK. So the defining of the materials is done. Now defining these materials to the slabs or footings would be done now. So define, go to slab properties now, click on add new property. Here by default we don't have footing or stiff because we are taking a grid only pattern, so no footing or stiff would be by default present. We have to define it. So click it as footing. So the slab material would be M40, and type you can change it as mat footing because we are considering it as mat footing now. So click on 500 mm. We'll assume it as 500 mm. So click on OK. Click on OK again. Now it's defining of the columns now. So go to define column properties. Click on add new property. Here we have two different type of columns as we have seen in the question. So let me show you once again the question. Here in the question you can see that we have two different type of columns, that is 500 into 500 and 600 into 600. So we will be considering two types of columns, that is column 1 and column 2. We will be defining only two types which will be having 500 into 500 dimension and 600 into 600 dimension. So let's come back to save. So column 1 will be naming it as column 500 into 500 and the material will be M40 and the dimensions would be 500 into 500. Just click OK. So one column has been defined now. So another column 600 into 600. So material will be again M40 and dimensions will be 600 into 600. So the materials also for the column has been defined. So now let's define the soil property. So go to define soil subgrid properties and you can see soil 1. So just modify or show property. you can keep the name as soil 1 only. So as we have calculated the subgrade modulus, that is 3 into 10 to the power of 4 kilonewton per meter cube. So let's change the value as 3e plus 04. So click on OK now. Even the soil property has been defined. Now just check the load patterns, load cases. So go to load patterns. You can see dead load and live load have been already there, so no need to add any load pattern. So go to load cases now. Here you can see both are in linear static type, so no need to change anything. Again click on OK. Now go to just define and load combinations now. Go to load combinations, add new combo. Here will be the combo will be combination 1 and the scale factor would be 1.5. Again here just click on live load and again click on 1.5. Just select the strength ultimate. Just click on OK. So one combination has been added. Now let's go to next combination. So combo 2, here it would be dead and here it would be live. So both values are 1 now. So now just select the service normal, service initial and service long term. Just click on OK now. Both combinations have been assigned. Now just click on OK. Now we'll draw the footing and the columns as we have taken grid only. So just go to draw and draw slabs and areas. So select draw slabs and areas. Be sure that it is footing here, and now just take the end point grid 19 it will be of 18. So this is just keep it here. 18 meters will be till here. So click on here and again 18 meters till here and again 18 meters. So just join at the first point again. So here you can see the footing has been designed. Now just cut this dialog box, just select the, just click on escape. You don't need anything here. Just click on, just select this footing area. After selecting this footing area, be sure that what you have selected, one area and 4 edges selected. So you have selected the footing area. Now just go to edit and go to edit areas and go to expand and shrink areas. So the offset value would be 2 meters. So it's not, I have done only 2 mm, so just hit undo. I have forgot that it's only in mm, so just go to edit again and go to select this area and just go to edit, go to edit areas and expand and shrink areas. So here it would be of 2000 mm because it's of 2 meters. So click on OK. So you can see that 2 meters on the edges have been expanded. This is done because we have seen in the question that we need to take 2 meters on the boundary. So let me show you. Here you can see that 2 meters on the boundaries have been expanded. So we have done this step. Now coming back to safe again. So now place the columns. So go to draw and draw columns. Let's draw the columns. So the property below would be none and the property above would be of 500 into 500 and the height below would be 0 and the height above would be 2 meters. So now let's place the columns very carefully as shown. Let me show you the plan once again so that you get a clear clarity where the 500 into 500 should be placed and where 600 into 600 should be placed. So you can see except the column 6, column 7 and column 10, column 11 and that's it. So column 6, 7 and column 10, 11 are 600 into 600 as per our question. So you can see the placements once again. So C1, C2, C3, C4, C5 would be of 500, C6 is of 600 into 600, C8 again 500, again 500, here C10 600, C11 600, C12 and the rest all are 500s. Let's come back to safe again. So clearly just place it here, one column, again at a spacing of 6 meters place another column. Now at a spacing of 6 place another column of I think I have done a mistake here, so just undo. So now again at a distance of 6 meters, now again at a distance of 6 meters, column 4, okay, distance of 6, column 5. So C6 is 600 to 600, so just leave that, and again column 7 would be the same, so leave again column 7. Now go to column 8. Now again with a spacing of 6 place column 9, column 10 is again 600 into 600, so just leave that, and column 11 is also the same, so leave that, and column 9. So with a spacing of 6 again, see that 1, 2, 3, 4, 5, 6, 7 have been left, 8, 9, 10, 11 have been left, and 12. This is 13, 14, 15, and I think this is, I have placed 1 meter less, so again, and the last 16. So the columns 500 into 500 have been placed. Now let's place column 600 into 600. We place it here. Column above is none. Column below is property below is none. Property above is 600 into 600. Height below is 0 and height above is 2 meters. So now just place carefully. C6, C7, C10 and C11. So all the columns have been placed in its positions perfectly. Now just go to draw, and now draw design strips. So just strip A will be in X directions, we will be in y directions. So as we have calculated before that the column strip width have been calculated as 4.5 and we have assumed it as 4. So just click it as 4, change every value as 4. So now just keeping here be sure that it is coming at the exact center of the column. So in the x direction we have just calculated everything. So now in y direction again the same. Here. So the grid lines have been also drawn. Just cancel it. So now it's time for assigning the loads. So click on the footing area carefully. Just press escape. can see one area and 4 edges selected. Just go to assign and just go to support data and soil properties. Soil 1, just check if the modulus of subgrade modulus is correct. It's correct, so just click on OK. So you can see the soil have been assigned. Now just let's assign loads on the columns. So now just carefully select the center of the column 1 and you can see 1 point selected. Just go to assign and to load data and point loads. You can see the red load is of 1850 as per the table, and just click on OK. Just click on the point again. Go to assign, load data, point loads, and this time the live load would be of 796.6. Just click on OK. Okay, here the size of the load I did not mention in the previous one also. Just let's change it again once again. So it will be 500 into 500. Just click on OK. Sign, load data, point loads, load. Now for the column 2, assign load data, point loads. Here the value is now for dead load, it is 3013.3. Dimensions would be the same. Click on OK. Select the once again point, go to assign, load data, point loads. This time live load is 1437. Do live load. Okay. Just proceed. Same procedure. So I have assigned all the properties here now. All the loads I have assigned on each column. So follow the same procedure and the way I have showed you before. I have just skipped because it is a lot of time. It takes a lot of time. So I have just skipped and assigned all the properties. So now let's assign the rebar materials to the footings and the strips. Just select the footing carefully, footing area. Now go to design, just right click on it, go to design, keep the rebar material as SISD 500, click on OK. Now for each strip also you need to do carefully right click on the strip, just change the rebar material as HYSD 500. So now in the y directions ones strips. Carefully select those pink lines and just so it's completed. Every strip, the footing also has been changed to the rebar material HYSD 500. So it's time for running the analysis. Just go to run and run analysis. You save the file as foundation. Allow it to run. So now you can see that the displacements graph is here. So now just go to run design, run analysis and design. Now go to display. First go to display, show punching shear design. So you can see that the values are greater than 1. So you need to change the dimension of the slab. So just go to define, slab properties, modify or show property. It's in lock. So just unlock the model. Go to define, slab properties, modify. I'll change it to 1000. Just click on OK. OK. And now just run the analysis once again. So now run analysis and design. Go to display and show punching shear design. So you can see that even though we keep 1000, we are getting more than 1. So let's change it. Just unlock the model. Go to define, slab properties, and this time keep it as 1500 mm. You need not keep 1500 mm, you can even keep less. Just be sure that the punching shear ratio is less than 1. So you can see all values are less than 1, so it is safe. So now just go to, you can see all the punching shear values are greater than 1, so just go to set display options, and you can extrude the extrude, there is extrude view, so just click on extrude view and just click on 3D design. So you can see the '3D view of the footing and the columns. Just place again in the XY direction. So now we are going to interpret the results. Before interpreting, just go to display. Just set cases and just remove the extrude view. Okay. Now go to display, show strip forces. So you can see the strip forces both in layer A and layer B at a time. We will see just moment. So you can see the moments in both layer A and layer B. If you want only layer A, just remove the layer B option. You can see the layer B. If you want the shear force, just you can click on shear force and you can see the shear force. So now go to display, go show slab design, and you can click on impose minimum reinforcements. Just apply. You can see the top width, the top and bottom will have the different. Now just cut this and go to display. Now go to show slab forces and stresses. Click on, you can see moment, maximum moment, or you can see the maximum shear or maximum forces. You can change the load to dead or live load, change the combination. We'll just keep the dead load and see what's it. So you can see that the displacements are here in the 10 to the power of -3, so these are very negligible. So now just go to display and show crack widths. You can select the bottom face or the top face. You see, just click on apply and you can see the cracks. These are very negligible cracks because it is 10 to the power of -3, so mm, so it will be very negligible, so no need to worry. So now just go to run detailing, click on OK. So here the detailing has been done. Just go to the model explorer in the leftmost corner of the screen, go to detailing, drawing component views, slab views. You can see slab views, and frame plan has been by default shown to you. So rebar table, so here you can see the rebar table. You can see every detail here, rebar schedule and bill of quantities. You can see, just go to individual slab design, just go to mat and rebar plan. You can see the rebar plan, top rebar plan, bottom rebar plan, and reinforcement profile layer A and layer B. Section 1, you can see elevation. Section 2, elevation plan. So this is the video on the foundation. Thank you for watching this video, guys, and please drop a like and do subscribe to my channel. Thank you.